My name, as I said, is Dan Shappir. I work at the Wix office in Tel Aviv. I am the performance tech lead at Wix, which means that, this is a joke I like to say more or less every talk I give, that on a good day I get to come home and to say that today I made 100 million websites load and execute faster. And then my wife goes like, oh hum, because she doesn't really care and it doesn't impress her at all. But for me, it's really something that makes me passionate about my work. Speaking about my work, I work at Wix. I know that Wix was already mentioned, but I would like to mention two things. I joined Wix approximately 4.5 years ago. When I joined Wix, we were 400 people. Now we're over 2,000 people, which is amazing to me. And about 50% of us are in R&D, be it test engineers or front-end developers or back-end developers or whatever. Another thing that I would like to mention is that apparently, more or less at the beginning of this year, we were chosen as the number 5 best software company to work for in the entire world by Glassdoor, which is really cool. And I can tell you that working in Wix is in fact a lot of fun, and I highly recommend it. Okay, so, oh, and of course we do have offices around the world, but in terms of where we have actual development offices, it's in the Ukraine, in Israel, where, as I said, I'm located, and here in Lithuania, in Vilnius. So, what will we be talking about today? Today we will be talking about testing for performance, and we will begin by discussing why performance is actually important, and at the same time, why is it such a challenge and actually becoming more and more of a challenge all the time. Then we will talk about the what of performance, specifically web performance. What is it that we actually look at or measure or consider when we talk about performance, specifically in the context of websites and web applications. I will talk about how we actually measure performance, various tools that we can use, and so forth. And finally, I will talk about how you can integrate performance testing and performance measurement into your release cycle to ensure that you keep progressing with your performance rather than regressing. So indeed, let's start with talking about the why of performance. The why can be fairly much summed up by this slide. Unfortunately, the numbers at the bottom are pretty small. By the way, the source for this slide is from a document that was published by Pingdom. Pingdom is a well-known company that deals with performance testing and measuring tools. And they released this graph as a part of the sort of the data that they collected about web performance and how it impacts engagements with websites. And what they have found, the numbers here at the bottom are basically seconds, which means the number of seconds it takes a website to load. And this one is basically percentages. And the interesting line for us in this case is the blue line, which basically shows bounce rate. Bounce rate basically means people who supposedly enter a site, but then effectively leave it before the site is actually loaded, before they actually interact with the site, before the site actually becomes engaging for them. So what we can see is that by 4 seconds, if a site takes 4 seconds to load, you're already losing approximately 25% of your visitors. And if the site takes 6 seconds to load, then, well, you're losing 50% of your visitors. And it just gets worse from there. I mean, at 8 seconds, it's around, like 10 seconds, it's over like 70%. You're basically almost losing all your users. And this is really, really critical, because what this means is that if your site is slow, your users won't wait for your site to load, regardless of how good it would be once it is actually loaded. Where will they be? They will be at your competitor's website. So you've worked so hard on making sure that your site is so great, has all these features, is bug-free, but everybody is going to your competitor's site, which is much more ugly and has all these bugs, but it loads so much faster. So they're there rather than at your site. And that's obviously not what you want. which means that making sure that your site loads quickly is one of the most important things that you can do if you want people to visit your site and to interact and engage with your site and basically drive your business. So this is another interesting thing. I actually got this from Tim Caddick. Tim Caddick is a well-known performance expert. I highly recommend searching him out, watching his talks on YouTube, on the web, reading his blog. He's really good. And he talked about this test that was made to see how users respond to slow loading sites. And it turns out that when people were forced to wait for certain slow sites to load, then 11% of them would start to actually yell at their phone. And 23% apparently started to actually swear at their phone. But the funniest thing for me is that 4% actually threw their phone away. Literally just took their phone and threw it at the wall or something. So think about it. This actually means that even if the user waits for the site to load, it's not one of those that just left the site. If the site takes too long to load, he will be annoyed, or she will be annoyed and aggravated. And obviously, if you want somebody to make a purchase, let's say on your site, because you're an e-com site, then obviously the last thing you want for them is to be really annoyed and aggravated by the time that they actually can see your goods and make a purchase. Another important thing to remember is that not all user devices were actually made equal. I mean, we build our sites, we test our sites, the developers have really high-end machines, we make fairly good salaries, so we can afford to buy the latest iPhone, and everything loads really nice and relatively quickly for us. But we tend to forget that a lot of people are actually using much lower-end devices, and of course, on lower-end networks. Obviously, this happens for people, let's say, in third world countries. But if you think about markets like India or China that are really growing, you want to be there. You don't want to just, throw these markets away because you're just testing on really, really fast and expensive devices. But it's not just that. I mean, have you ever taken your phone and then went to some other country, or just, were on vacation where there was an area with bad reception, or just walked into an elevator? You know that sometimes even your supposedly great connections are not that good. And then you suddenly find yourself having a connection that's kind of similar to what these people experience on a day-to-day basis. So again, even if it seems to load fast for you because your device is great and your network is great, you need to take into account that it's not the same for everybody else. So I was talking about the fact that we want our websites to be faster, and I think I gave a pretty compelling case to why that is. But I also said that it's becoming more challenging, and this is one of the main reasons why. Looking back just 6 years, average sites were under 1 megabyte in terms of the amount of content that they downloaded. Now, just 7 years later, we're over 3 megabytes. So we've increased the total download size of the average website in just 6 or 7 years threefold. Now, obviously, networks, devices, whatever, have gotten faster, but we've not become 3 times faster across the board. And again, there are a lot of people out there which have devices or networks today that are equivalent to what you might have had 6, 7, 8 years ago. And we're leaving these people behind. So we keep on saying that we want everything to be faster, but we've effectively doing everything in our power, it seems, to make things slower. Now, this is just the overall download size. And this, by the way, the source for this is from a report by a company called SpeedCurve. I'll mention them later. They're another very interesting company that works in this space, and they also have tools for monitoring performance and testing performance. So they're also worthwhile to look at. So another interesting graph that they provided is how this extra download actually breaks down into different resource types. Now, it's not really surprising, I think, that we will find that what keeps on growing all the time is media. That could be images, that's the green bar, or it could be videos, that's the purple bluish bar here at the end. So but you know, across the board, everything seems to be growing. Probably the only thing that isn't growing is the actual HTML itself. HTML actually apparently remains more or less the same size, but everything else keeps on growing and growing. And one of the things that keeps on growing is the JavaScript. That's the reddish thing. As you can see, from here to there, it's much bigger. For some reason, we were making headway, making it small in 2017, but up until that point, it just kept on growing and growing and growing. And that's really important because in the case of JavaScript, you're not just paying for the download. It's not just the cost of downloading all these bits. When you're writing JavaScript, that JavaScript, when it's downloaded, needs to be parsed. And after it's parsed, it's probably going to be run. So you're going to actually pay for this JavaScript again, not just in the download phase, but also, as I said, parsing it and running it. And how much are you going to pay? Well, that, it turns out, really depends on the device that you're using. This is a very interesting graph that basically shows the amount of time that it takes to run a certain amount of JavaScript. I don't remember actually which website or web app they were testing, but they were basically running the same JavaScript on various types of devices. And we can see that while it ran fairly quickly on iPhones, it turns out, surprisingly or not, that an iPhone 8 is probably when this report was made, was probably the best thing you could do in terms of JavaScript performance. It actually ran JavaScript faster than the MacBook Pro, which I found fairly surprising. But just compare it to a $100 phone. The $100 phone runs, like 30 times slower? More? That's horrible experience. I know somebody, one of the people who's really into the performance space, and they actually intentionally went out and bought one of these phones and then used it for a while just to get the experience of what it feels like to use one of these low-end devices in terms of the web performance. And he basically said that it was essentially unbearable, that he just couldn't stand it anymore and just couldn't use the web because the experience was just so bad. So it'll be awesome if everybody were to get the new iPhone X, but unfortunately that's not the case. People still use low-end devices. I think millions of them have been sold in Europe last year, so a lot of people are using them. And you don't want to necessarily miss out on all these people as potential customers. So you need to take that into account. So again, JavaScript, it's like the gift that keeps on giving. It's not just the download time, it's also the execution time. Okay, so we talked about why performance is so important, and at the same time, why performance is such a big challenge. But what exactly is performance? When I keep on talking about web performance, what is it exactly that I mean? Well, it turns out that Google has this really cool model, which they call RAIL, which is the acronym they use. Americans really love acronyms. But I actually really like this model because it more or less covers all the bases. So it talks about performance across essentially 4 categories, 3.5. The R is for response or responsiveness, A is for animation, I is for idle, and L is for load time. So responsiveness basically is the amount of time that elapses from the time at which the user, let's say, clicks on something, let's say click on a button or a menu, and until there's a response to that interaction. Like you click, how quickly does something actually happen in response to that click? Or you swipe, how quickly does the page actually move in response to this swipe? And by the way, in the context of these devices, the mobile devices, responsiveness has become really, really important, because when it's your actual finger that does the thing, when it's so tactile, people really expect it to be highly responsive. People get extremely annoyed when you do something with your finger, you swipe, and then everything is like stuck, and then after a while it kind of moves. It really freaks people out. People really hate that. So in terms of responsiveness, the goal is to be under 100 milliseconds. So at most you want 100 milliseconds to pass from the actual interaction until there's actual response to the user. That more or less means that you have like 50 milliseconds more or less to finish whatever other task you were doing at the time that the user interacted, and then another 50 milliseconds more or less tops to actually process that user interaction and respond to that. If any one of these two is longer, then what you're going to get is an application that seems kind of unresponsive. Animation is about the smoothness of animations that take place when the user is interacting with that application. So for example, let's say you have an application where I can drag things across. So responsiveness would be the amount of time from when I put my finger and then start dragging until that thing starts to move along with my finger. The animation or the frame rate talks about how smoothly that movement seems to be. In an ideal world, we want animations on the web to be 60 frames per second. If we can't do that, then we can live with maybe 30, but the ideal is 60. By the way, as a point of comparisons, your TVs have or used to have 24. So we really want 60. By the way, for 3D, web VR, stuff like that, they're talking about 120. Now, when you're talking about 60 frames per second, that means that you have more or less 17 milliseconds for each frame. But in reality, the browser also needs a little bit of time. So really, what you really have is anywhere from 11 to 14 milliseconds to do everything that you need to do in the context of every specific frame. You do more than that, you're going to overrun your frame time, and you're going to get what is known as jank, when animation seems kind of jerky and not smooth and not consistent. And again, users don't like that. Idle basically means that when you need to do some sort of a lengthy process, you will do it in your idle time. You will break it into 15 milliseconds chunks so that you can be responsive. Or alternatively, in a modern web, if it's possible, you might shift it off to a web worker. But that's kind of like the future of things. And finally, last but certainly not least, is the load time. In fact, when people today usually talk about website performance or web app performance in the context of the web, usually what they talk about is the load time. So let's talk about load time. So let's say I have effectively a blank browser, and I click a link, or I put some address in the address bar and I press enter or whatever, and the page starts to load. So initially, I basically see nothing. And then, after some time, something will happen on the screen. That's referred to as the first paint. First paint is basically some pixels on the browser window change from their initial value of nothing or white to some other color which was specified by the web page. As you can see, there's not a lot of meaning here. It doesn't really give the user any value, aside from the fact that the user feels that something is actually happening in response to that initial operation of, let's say, clicking the link in the Google search or whatever. So that's first paint. The next one is First Contentful Paint, or FCP. First Contentful Paint, as its name implies, basically means that it actually puts some sort of meaningful, well, not meaningful, but some content that the user can actually identify. It can be some text, it might be some image. In fact, FCP, or First Contentful Paint, is defined as being pixels that have changed in the browser that are part of text or image or SVG or canvas, but really it's text or image. So as opposed to just some sort of background color, this is actually an image and text. That's First Contentful Paint. The next one is First Meaningful Paint, or FMP. Now, what's the difference between Contentful Paint and Meaningful Paint? Well, Contentful Paint might be, let's say, the logo on the website. It's, it's nice to see that I'm actually at the website that I expected to be at, but it doesn't really provide something useful for me. Meaningful in this context is something that has meaning for the users visiting the site. It might be different depending on what the site is. So for example, if it's a news site, then the First Meaningful Paint might contain the headline of the main story and, let's say, the image from the main story. If it's, let's say, a weather website, then it would contain the actual temperature and maybe also the image that shows whether it's raining or sunshine out there instead of opening the window and just looking out. So that's the difference between the First Contentful Paint, which shows just any old content, might be meaningful, might not be meaningful, versus the actual meaningful content. Hopefully this is clear. By the way, if anything I'm saying is unclear, feel free to raise your hand and stop me. Okay, so we got some more content on the page. And finally, we have essentially the site is effectively ready or almost done. And we've got what is known as time to interactive, which means that the site actually now responds to actual user interaction. So previously it was almost like just pictures, not necessarily responsive to whatever the user might do. Now when it's interactive, it means that the user can actually click things and the site will actually respond to the user input. Now obviously all these might happen together at the same time. So you might have nothing, 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 and then boom, you get everything together. Although best practices today is to try to to build the site gradually. So you usually get this sort of a breakdown of first paint, contentful paint, meaningful paint, and finally the time to interactive. Now, in terms of the time frames, the recommended time frames that today very few companies actually are able to achieve are something like 1 second to 1.2, 1.3 seconds for First Contentful Paint, and 3 to 5 seconds time to interactive. Those would be the ideal values, and don't be ashamed if you're not there yet. It just gives you, sort of a goal that you may want to achieve. It's not an easy goal to achieve, to actually get these low values, especially on slower networks and lower end devices. Okay, so we talked about what performance actually means, the various things that we might want to measure, like First Contentful Paint and First Meaningful Paint. But how do we actually go about measuring them? Which tools can we use for that? Before we look at the actual tools, I want to mention this quote. It's been attributed to Peter Drucker. He was not a performance person. He was not a test person. He was a management consultant, but a very well-known one. And a quote that is attributed to him basically says, if you can't measure it, you can't improve it. In our context, if you want to be able to measure performance, to improve performance, we need to be able to measure performance. So how do we go about it? So first of all, let's talk about when can we measure performance. And it turns out that we can measure performance at 3 main stages. We can measure performance, obviously, during development or, let's say, manual testing on the local device. I can basically download the site on my device, and I can literally sit there with a stopwatch and see how quickly from clicking the button until I get the First Contentful Paint or the First Meaningful Paint. Alternatively, I can use tools like the Chrome DevTools to actually have the computer measure it for me instead of doing it myself with a stopwatch. At the other end of the spectrum, I can use what is known as real user measurements, or RUM, which basically means that I've used, let's say, either something that I developed or a third-party tool that I've integrated into my website, and I can actually gather performance data from the field. And by the way, Google actually, and I'll talk about it a little bit later, actually now provides a lot of such data that they collect for you for your own site or for even your competitors' sites, and you can actually look at that as well. And of course, you can actually do it in the middle during, let's say, automated testing using synthetic sessions. So synthetic sessions is basically sessions that you run automatically, let's say, in containers or in a virtual machine or whatever. It might be anywhere in the world, and you just run them, and gather performance metrics from them, so you can gather performance data from these sessions that just run automatically all the time, and basically hit your application, download the site, and you gather all the performance data for them. So which tools would you use to measuring performance? So one really well-known tool that I really love is a tool called is a website called webpagetest.org. Highly recommended if you've not used it. By the way, I will provide this slide to all the, in the comment section of the meetup, and all these are links, so you can actually go there, but essentially just webpagetest.org. It's a really powerful tool that provides you with a lot of information about the performance of your website, how long it took to download the various resources. I will actually show it, or show for a particular site in a bit. Google Lighthouse. So Google have built this tool called Lighthouse. The image is actually the logo for this tool. They keep on talking about it all the time. They're really pushing it. That's a really more kind of a high-level tool, whereas webpagetest.org really drills down and shows you the low-level stuff. Google Lighthouse actually gives you a kind of a higher-level view of like a total score, performance score for your site. Again, we will look at how it looks for a particular site. Lighthouse is actually, Google loves it so much that they've actually built it into Chrome DevTools. So if you open Chrome DevTools and go to the audit panel in DevTools, that's actually Google Lighthouse. But you can also run it in other places. Google actually had a lot of sites and tools that they provided for measuring performance, and it kind of created confusion in the market, because you might get a good score in one tool and a not so good score in another tool. So basically, a few months ago, they said enough's enough. And at the recent Chrome Developer Summit, they basically stated that they've standardized all their tools on Lighthouse. And now PageSpeed Insight, for example, that's another Google site that used to have a totally different test, now effectively runs Lighthouse and gives you Lighthouse results. And there's also another site that essentially does the same thing, which is called WebDev. And what's cool about WebDev, by the way, is that it's also a progressive web app, which means that you can literally install it on your smartphone and then just run Lighthouse tests on whatever site you like, wherever you are, whenever you are. If you're just vacation and you have nothing to do, then you can run performance tests for all sorts of sites. And interestingly, these two tools have actually been combined, so you can do webpagetest.org/Lighthouse. And what's cool about that is that you can actually use that to run Lighthouse in various different locations in the world. So instead of just seeing the Lighthouse score for Lighthouse test running where you are, you can actually run Lighthouse, wherever in the world you would like, and get the score from there. Online tool that you can also launch, put in your website or some other website, and also get performance measurements for it. So let's show a really quick demo. I'm not going to delve too deeply into this. I'll just show it quickly, and we will move on. So this site is actually the BBC News site. The BBC are actually well known for doing really good work in terms of performance. By the way, much better than CNN. It's really funny. I actually give it as an exercise to actually try to compare the two and see how much better the BBC site is in terms of performance than CNN is. So if I click Lighthouse, this is actually the PageSpeed Insight website. I'll make it slightly bigger. It's now actually literally running the test, and wow, they got a 90 here. The last time I ran it, they got only 80, so either it's because I ran it in Israel rather than here, or alternatively, they've made things even better. But anyway, what they give you here is a really useful value in terms of an overall score, which in 90 really means that their site is fast. 50 to 90 is average, below 50 you're kind of slow, at least according to Google. Now, what do they, I'll go back up in a bit because that's really interesting, but before that, So we already mentioned First Contentful Paint. So they get 2.2 seconds. Now you remember that I said before that you want to be 1.2. They actually run this simulation, these results are for a 3G network. So for 3G networks, they're willing to make concessions, and I think that 2.4 and below, in this context, they actually rank as good, something like that. First Meaningful Paint, we talked about it before. Interestingly, as you can see in this case, First Paint and First Meaningful Paint were the same. We can actually look down here, they give you sort of a film strip that actually shows you, so you basically had nothing, and then essentially almost everything. You can see some images loaded a bit later, but the meaningful stuff, which is the main picture and the headline text, was available from the get-go, which is why both Meaningful Paint and Contentful Paint have the same value. Speed Index talks about how the site kind of builds. I won't go into that. There are a lot of articles you can find about it. First CPU idle is another measurement, basically checks to see how soon does the site actually become responsive to user input, in the sense that the CPU is mostly idle and consequently can respond to user interactions within that 100 milliseconds that I mentioned before. Time to interactive, 4.3 seconds. So you see the site was effectively visible at 2.2, but only really became interactive approximately 2 seconds later. So for those initial 2 seconds when the site was actually there, if the user tried to click something, then maybe nothing would actually happen. Now, we can live with that because people don't usually start clicking immediately on whatever. You know, they see something, they kind of think, what do I want to click on? So that gives us a second or 2 or 3 to actually make the thing interactive. But you can see that while Lighthouse really consider these values to be really great, this one is kind of considered mediocre. They also list various opportunities that you can use to make your site basically even faster. They kind of run all sorts of, give you all sort of suggestions based on various heuristic rules that they have. I won't go into them, but again, I highly recommend that you look at them. Now, this is also very interesting. Turns out that when you install Google Chrome on your device, whatever it may be, there is an opt-in or opt-out, I forget which one they use, which basically tells you that we are going to collect anonymous data from your sessions. Is that okay or not? And a lot of people, like, I don't remember if you have to turn it off or turn it on, but essentially it's on for a whole lot of people. And it turns out that some of the data that Google is collecting is actually performance data, and this is it. So what they're showing here is actual performance data from real live user sessions. Again, anonymous, so you can't get the name of the person who was unfortunately getting such slow performance. But you can see that for 44% of the people, they got really good performance visiting this site, 45% not so good, and then 12% got really bad performance. But the average or median, I forget which, is 2.7. There's also first input delay. I already mentioned what that is. And by the way, before I leave this, it's worth noting that all this data, Google actually makes it possible. They actually expose it. You can run big queries on this data. There's the HTTP archive and the Chrome user experience report. You can actually search for those terms. You will find that you can actually run queries on them. So you can run, even if you haven't instrumented your own application, if it's popular enough and there's enough traffic for it, you can actually get performance data about your application and about your competitors' applications from that database. Okay, switching back to, let's look at web page tests. The web page test one I'm going to do fairly quickly. So the reason that this loaded so quickly and didn't actually run the test is that web page tests have this concept of permalinks. When you run a test, it actually saves the results and you can actually send that URL to people. So let's say you're doing a test and you want to show something to one of the developers or one of the product managers or whatever. Instead of them having to run the test and maybe reproduce the real results or maybe not, you can actually send them the link and they will see the results that you got. So your results are kind of saved and you can send them on. Again, I'll make it slightly bigger. So this is actually, as you can see, a much deeper drill down. You actually have something that's kind of similar to the Chrome DevTools network tab. If you've ever looked there, you can actually literally see how the various resources downloaded, how long it took to download and each resource and the various stages. The green, by the way, is the DNS. The orange is the TCP handshake. The purple is the SSL handshake. And then you actually have the actual request response downloading the actual data. So it gives you a really detailed view of how long it took, how many resources were downloaded, and how long it took to actually download each and every resource. Really interesting, at least for technical people like me. And then you also have high-level views. You have high-level views that basically, again, shows you how long the time to first byte, the start render time, and other values. By the way, one really interesting thing here, highly recommended watching, something called the film strip view, which again, kind of similar to what we saw previously with Lighthouse. It actually shows you the screen at various stages. And by the way, I don't know if you can see it, there's an actual red line that moves here as I move between the strips. So I can see which resources were downloaded up to a particular image. Kind of gives me an indication of what I'm waiting on in order to get a certain content drawn on the screen. Again. So this is kind of more technical and low level than Lighthouse, but it's very useful. And I highly recommend, there's a lot of documentation about it, and I highly recommend investing effort and time in order to study it. Let me see if I can make this full screen again. Okay, so we saw various tools that we can use to measure performance and see whether or not our website has good performance. But what about if I want to actually integrate it into my own automated testing process, or maybe into my continuous integration process, or maybe even I have continuous deployment, and I want to avoid accidentally deploying a version that regresses performance. How can I go about doing that? So when you're thinking about automatically preventing regression, avoiding releasing versions that degrade performance, then a key term that you need to be thinking about is something called the performance budget. And I'll really only touch on that, but again, if you search for it on the web, you can find a lot of articles and presentations about it. Adi Osmani, from well-known performance specialist from Google, has written a really interesting article about it. Likewise, Tim Kadek also wrote about it and spoke about it. So basically, performance budget means that it's a limit that you decide to set on your pages, on your website, on your web pages, on your web applications, that you are not allowed to exceed. If you exceed those limits, then effectively the build breaks. It's like a bug. If it's above this value, it's a blocking bug, and you're not allowed to release the application. What might it be? It might be the maximum JavaScript bundle size. You might decide that under no circumstances is my total JavaScript download allowed to exceed 300 kilobytes. If it goes above 300 kilobytes, then that's a bug, and I won't release it. Now, obviously, that's a very harsh restriction. I mean, what happens if you're at 294 and you've decided to add another feature, and now you're over 300. So what, we don't put in features anymore? It's a difficult decision. You might decide that there's no choice. You have to increase the limit. In fact, if you're already at 290 and your limit is at 300, you're kind of, it's like driving on a really almost empty gas tank. You're probably going to have to make a decision about stopping at a gas station. So here it's like you need to make a decision about whether or not this performance budget is realistic for you, or alternatively, if you're going to sit down and invest significant effort in actually reducing the total size of your application, maybe removing all sorts of code and stuff that nobody really cares about anymore. It might be the total media weight. You know, we have designers that like to put in the best looking images, and it has to be PNGs because they have to be pixel perfect and whatnot. So you need to think about, you know, the total size of your media. Do you really need to have, I don't know, 20 different fonts on your page? It's probably not such a good idea from usability and visibility perspective, but it's certainly not a good idea from a performance perspective. Same with images, same with videos. Don't use GIFs. Use videos instead. It might be a specific load time. If your time to interactive on, let's say, simulated 3G is over 5 seconds, you might say, that's too long. I need to cut something out. And people have been known to make very difficult decisions. I was at a talk at a conference recently where a store, they built a website for selling, it was an online clothes retailer, and they had this really cool ranking feature that the customers could actually put like an amount of stars on certain items, and it turns out that it was really popular and was driving sales. But then it turned out that that particular feature made their site unacceptably slow on Android devices. So they made the difficult choice of not providing that feature on Android. They provide it on desktop, they even provide it on iPhones, but they don't provide it on Android, even though it was such a popular feature that drove sales, because their bounce rate was just too high when they had that feature enabled on Android devices. It might be on the Lighthouse score. I mean, we will touch on that in a minute, but if I can run Lighthouse automatically for builds, like every build or every once in a while, once a day, I'll run a Lighthouse score, I can look at the Lighthouse score, I can actually get that value. And if my Lighthouse score, let's say, goes below, let's say my current Lighthouse score is 60, I can decide that if my Lighthouse score goes down below 50, I consider that a blocker bug, and I won't deploy that version. It needs to be fixed before that version can be released. So how can I talked about various performance budgets. Now let's look at the tools that can actually enforce them. Don't worry, we're close to the end. I know this has been a long day. So there's a nice tool that doesn't actually enforce a performance budget, but it can be used to calculate your performance budget. Because if you come up with a performance budget that's not something your company can attain, that your software can do, then what you will do is actually potentially do more harm than good. If your software currently if your website currently takes, let's say, 8 seconds to reach time to interactive, then saying that my performance budget for time to interactive is 6 seconds effectively means that I can't release any newer versions of that software until I make some drastic improvement. And that's probably not something that you can do. So you need to make sure that you choose attainable performance budgets. And one tool that you can use to calculate a performance budget that on the one hand is something that you can attain, but on the other hand gives you the performance that you want to achieve, is this performance budget calculator. So one interesting tool is a tool called bundle size that you can actually put into your build process. Basically measures the size of JavaScript bundles or packages, and if they grow too big, then it breaks the build. Webpack actually has this capability built in, so you can have Webpack either issue a warning or an error when a bundle that Webpack builds actually turns out to be too big. Again, webpagetest.org, I mentioned it before. It turns out that webpagetest.org actually has an API, and you can actually either set up your own VMs that literally run webpagetest.org. It's an open source software. You can actually download and install it and run it on your own devices, or you can actually connect to the free service that's out there, but then you have various restrictions on how many sessions you can run and so forth. But you can actually use that again to drive value, to get values into your build process. Turns out that Lighthouse itself can also be integrated into your build process. This is actually something that we are currently doing at Wix. We're actually integrating Lighthouse into our build process, and there's this, it's not too difficult to do yourself, but there's actually this project called Lighthouse CI, which basically provides this for you kind of out of the box, and you can use that. I already mentioned SpeedCurve as a company that builds tools for performance testing, performance monitoring, and they have tools that you can use for enforcing performance budgets. And they look to be really cool tools. There's also this open source tool called, I think it's pronounced Gary, something like that. I don't know. I've not yet actually used it, but looking at the site and what it says about the services that they provide, this also looks like a really interesting tool, very powerful for implementing performance budgets in your project. So to kind of sum it all up, and yeah, we're at the point where we're summing things up. If you don't test for performance, it won't happen. In fact, from my experience at Wix, if performance is not progressing, it's regressing. If your performance isn't getting better, then it's likely getting worse. And that's not the way that you want to be going. And so in order to improve performance, in order to ensure that you get good performance, that it's improving, that it's not regressing, you have to understand your performance requirements, what is expected from your software. You need to set realistic performance budgets. Like I said before, if they're unrealistic, nobody is going to be able to achieve them. And then everybody will go around feeling sad, but you've not really done any good. So set realistic performance budgets, and then down the line, once you achieve them, you can make them even more strict and get even faster performing software. Then you put in tests for these budgets as part of your continuous integration process, so the build can literally break and prevent deployments when you exceed your budget, and like I said, fail on performance regressions. So I wanted to thank you all from listening to my talk and coming for this day and staying so late. Thank you very much.